Perfect.
Oh, wow. Very
All
nice.
set? Okay.
Yeah. Good.
Hi everyone. I'm going to be talking about the chemistry of waterproof clothing and PFAS in general. So going back to the history of waterproof clothing, in the 1940s and 50s, there were a lot of chemical companies like DuPont and 3M that were creating these new compounds that were revolutionizing a lot of different industries, but also the clothing industry and like outdoor apparel. And they were making these new compounds that were fluorocarbons that could be applied to so many things like our clothes, cookware, really anything that we needed to kind of like repel water, dirt, stains, things of that nature. And at the time, there were not a lot of like coatings and compounds that could do this so well. So it really kind of revolutionized kind of like what we could put on our clothes and things like that. And this is just a picture from the 1940s of a chemist at DuPont kind of synthesizing these chemicals. So what are these fluorocarbon chemicals? Oh, perfect.
Yeah.
Is that good? Okay. So these compounds are man-made and they have these long chains of fluorine and carbon. And there are like thousands of them that have been synthesized and they're constantly creating new ones. And as we learned, the bond length and bond strength are related. So these carbon and fluorine bonds are very strong and stable because they have very short bond lengths. And that gives them a lot of unique properties that I'll talk about. And so these fluorocarbon chemicals, they have a lot of different names because there are thousands of them, but we'll call them PFAS is what they're commonly known now. So looking more at the structure, you can see that they have these long fluorine carbon chains on one side, and those are hydrophobic. So they repel water, they don't like water. And that is because of what we talked about in class today, because fluorine is highly electronegative, so it doesn't really create these temporary dipoles. So the London dispersion force that we were talking about. So there's low intramolecular attractive forces. So when water will kind of like hit these surfaces, there's low surface tension. And you can see that these fluorine carbon compounds are kind of like stacked up and there's no space. It's really dense. So the water will kind of like cool and then drip off. And so that's kind of the chemical structure. And it is really unique because of these very strong carbon fluorine bonds. So that creates a ton of great properties. So as I said, water and oil repellency and like flame retardancy. So all of the like the firefighter foams or things that we have PFAS in them. A lot of chemical resistancy and weatherability. So a lot of like electronics and things have them in them, and lubricity and electrical properties. So almost everything we use has this coating, this PFAS in it, which is great because of all these properties that it has, but it also has a lot of negative side effects. So this video will shortly explain that.
1946, DuPont introduced non-stick cookware, which featured a chemical coating with the brand name of Teflon. Today, the entire family of fluorinated compounds, commonly known as PFAS, is found not only in pots and pans, but also in the blood of nearly all people around the world, including 98% of Americans. It's even found in the blood of newborn babies. But how do chemicals used in cookware get into our bodies? PFAS chemicals are used in a staggering array of consumer products and commercial applications, from non-stick pans to stain-repellent carpets, waterproof clothing, fast food wrappers, and firefighting foams. PFAS are even used in personal care products and cosmetics. When we make, use, and dispose of these products, PFAS are released into the environment, including the water that we drink and the land that produces our food. Because they contain a strong carbon-fluorine bond, PFAS don't break down. They can remain in the environment and people for decades. That's why they're often called forever chemicals. The PFAS family of chemicals, which includes thousands of synthetic compounds, is concerning because even extremely small doses of PFAS have been linked to serious health harms. These include increased risk of cancer, hormone disruption, accelerated puberty, liver damage, thyroid disease, and immune system harm, such as reduced vaccine effectiveness. For decades, chemical companies have covered up the evidence of health hazards linked to PFAS. Today, more than 200 million people in the US may be drinking PFAS-tainted water.
Okay. So that video kind of explains some of the negative, harmful side effects that we're now realizing of these coatings and PFAS chemicals. And this diagram just kind of shows the cycle of how it lasts in our environment and ends up getting into our bodies. So either through the clothing that we wear and the packaging in our food, it can get into our homes and then into our bodies. But also just these chemical companies that are producing these compounds can also discharge water that goes directly into our groundwater or through wastewater treatment plants that haven't until very recently been testing for PFAS. So that also gets into the water. And when we throw things away, the landfills will collect PFAS that can get into our water, and that will then either contaminate the fish and food that we eat, but it can also get into the soil and dust. And so all of these different pathways end up into our bodies, and we're not able to break down PFAS because of these strong bonds. And so it just builds up over time as we stay alive. So this is a map that the EPA recently has been going around testing all public water sites. And you can see that there are thousands of areas that have high levels of PFAS that we're drinking and being exposed to. And like zoomed into the Bay Area, there are lots of sites around us that have concerning levels of PFAS that need to be addressed. So it is a local problem. So a lot of companies and nonprofits have been putting pressure on clothing companies to kind of reduce or eliminate the PFAS that they're putting on their products. So the NRDC kind of created a scorecard of different companies that are doing either really good jobs or really bad jobs at taking PFAS out of the materials that they use. And a lot of companies are not doing a good job. Thankfully, there's been a lot of regulation recently. So just last month, the EPA created a contamination maximum that can be in our drinking water at 4 parts per trillion, which is a really small amount. And they hope that that will get down to 0 over time. So now any of our water treatment systems or what's going through our taps needs to be tested and brought down to 4 parts per trillion. A lot of states are also doing their own sort of regulations. So places like California are saying that companies need to be transparent if they're putting PFAS on our clothes or in our food containers or on our pots and pans. So that gives us a lot of information. And then starting next year, California will prohibit textiles from being manufactured or created or sold in the state if they're more than 100 parts per million. So there are ways that people are taking action at the federal level now that we know how dangerous PFAS is. So looking ahead, what I took away from this is that we need to keep being aware of these chemicals that are getting into our bodies and kind of putting pressure on these clothing companies and other companies that are just like readily using PFAS. And also you can do research to see what companies have committed to taking it out of their clothing. And also there's a lot of databases to see what companies have PFAS-free clothes, products, things like that. So there are a lot of resources out there now that there's so much awareness. So that's my project. Thanks.
So